The freedom to experiment with computer science.
Teamwork.
Interesting.
Advanced.
Creative.
Innovative.
Exciting. Fun.
Through computational thinking and computer science, our students at ASL are empowered to think critically, solve complex problems, and embrace innovation. We aspire to create a dynamic, cross-disciplinary approach that equips students with essential digital skills and ignites their passion for creativity and collaboration. Through computational thinking, students learn how to formulate problem definitions, recognize patterns, break down those problems, and create solutions that use algorithms. And our computer science program is designed to give students an opportunity to elevate their digital skills through things like coding, app development, modeling and simulation, and much more. In this video, we'll showcase some of the many ways that our students are diving into CT and CS and inspiring their peers and their teachers to cross-disciplinary boundaries.
So computational thinking, or CT, is not only used within TILM or technology classes for things like coding or troubleshooting their devices, but it's also intrinsically integrated throughout the curriculum in areas such as literacy, math, science, social studies, and more. For example, when students are using first, next, then, and last for their writing or to sequence a retell of a story, they're actually using computational thinking skills, decomposing numbers and breaking down problems into smaller parts, taking basic concepts of sorting, classifying, and pattern recognition. These are all aspects of CT. In TILM specifically, we do unplugged activities or device-free activities to get our brains warmed up and ready to learn. These activities usually have a focus on building teamwork, communication, algorithmic thinking, and problem-solving skills that can be applied to many areas of learning. By working with CT skills, students use persistence, creativity, and collaboration in that problem-solving process. And these are all important lifelong skills for our 21st century learners. I think we can spark their passion, their curiosity, their imagination in the lower school with all of the resources that we have here, such as the LEGO Robotics, LEGO Spike Essential Kits, and I know they use Spike Prime. It's a perfect example of the continuation or the progression from lower school to middle school, high school, and beyond.
In middle school, the students are building on the skills they learn in lower school. And one of the interesting things is that computational thinking isn't just about math or science courses. One example might be in social studies, when they're looking at what are the causes of World War II, looking at a whole range of data sets, and then going through a step-by-step process to see if they can come up with what were the reasons why World War II started. In any of the video or audio electives or after-school programs, there's a whole range of steps that you have to go through, from planning, coming up with questions, doing the interview, working on the editing, and then putting the production together in order to have a successful project. And all of that involves computational thinking.
There's a variety of ways that students are getting exposure to computational thinking. That could be through virtual reality, VR, augmented reality, AR, 3D CAD and modeling, web design, game and app design, robotics. We're seeing students applying their own knowledge to work with existing code to create their own code or to manipulate that code in different ways. End of the day, technology is just a tool, and it's been very exciting to see how students are using that tool, mostly because technology has given them the ability to take their learning and their understanding and take it in lots of different directions. So whatever they're interested in, whatever they're passionate about, technology can support that. Our role is just to use computational thinking to help guide how they're using the technology.
The most exciting project I've done has been a game and app development.
We are making a lamp with 3D printing and laser cutting.
I'm trying to move my robotic hand, or hopefully what I can call prosthetic soon. Sort of interpreting the electrical signals from my forearm, create those movements.
I do drawings on the iPad. I like coding, and we get to do lots of coding, and I love building.
But then once you get to a place where you can sort of start you have enough utilities in your head that you can sort of start taking different classes and have the different classes interact with themselves on a project of your design, then it's like really a beautiful thing.
Right now we're building a robot to play a game, and me personally, I'm building a mechanism to be able to pick up the game pieces.
The availability that the teachers and the knowledge that the teachers have is so great. Like with my project, I've had a lot of help with some of the teachers that are not directly related to this course, but they were able to take some time out of their busy schedules to help me, which I'm very grateful for.
Using technology, me and my friends created a toy company.
I've been building the drone launcher, which is to launch a paper plane into the
landing zone, and I'm competing in the FTC center stage.
I have really enjoyed data science because it allows me to explore data and see how it affects people.
Now, what is your favorite food? Batteries.